Hi, welcome to Datafied YouTube channel. This is a series on list comprehensions and I want to welcome you to this video. If you're yet to subscribe to our YouTube channel, please do so, which will enable you get notifications whenever we post our new videos. In this video, I'll be running through some interesting concepts about list comprehensions. I like to demystify the concepts, so I'll employ that you go through all the videos in this series. And here are my learning objectives. In this module, of course, this is going to form a module for those who are taking our data analytics training. We would learn how to understand the list comprehension syntax. We explore different ways to apply list comprehensions and implement your own list comprehensions. So here the overview. The module is structured as follows. First, we'll begin by looking at the overview of list comprehension syntax. Next, we would look at list comprehension examples, and then some exercises will follow. By way of introduction, list comprehensions are equivalent to set builder notation. For those of you who remember your elementary mathematics in set theory, there are different ways of describing the elements of a set or describing a set. We have the listing method, we have set builder notation, we have Venn diagram, and all. So for list comprehension, it is equivalent to set builder notation. This is where a set is constructed using an expression that describes what should be contained in it. And here's a typical example of a set builder notation. So this set reads as follows. It's a set that contains all elements x squared such that, so this pipe or vertical line represents such that x is a member of z, which means x is an integer, and x is within this interval. X is less than or equal to 0, and x is strictly less than 5. So here is a set builder notation of representing elements or the square of all the numbers between 0 and 5 not inclusive. 0 is inclusive, 5 not inclusive. All right, so when you're looking at list comprehension, it's just an exact replica of set builder notation. Now, I just explained what I said in text here. It says this set refers to the squares of a set of all integers x such that x is greater than or equal to 0 and less than 5. And when we want to list, if we're interested in listing the elements in this set, we have 0, 1, 4, 9, 16. Because the square root of 0 is 0, the square root of 1 is 1, the square root of 2 is 4, the square root of 3 is 9, the square root of 4 is 16. Because this is a strict less than sign, 5 is not part of the domain of this set. So list comprehensions are a compact way to create lists in Python and can sometimes be more efficient. So most times when you're writing your functions, there might be reasons for you to use your list comprehensions to create or to generate some elements, which will be more efficient way of executing such tasks compared to the for loops in Python. Let's briefly look at the list comprehension syntax. The list comprehensions are always returned as a list, and that is why it's called list comprehension, right? The general syntax is as follows. We have the open square bracket, which represents the creation or beginning of creating a list. When you're creating a list, you start with an open square bracket, and then you return the computation on this item, right? So you're going to return the computation of this item. Whatever appears first is what you want to see, the elements in the set, just like you have x squared here. Now for item in list, if item satisfies some given conditions. All right, so exactly like we exactly like I mentioned about the set beta notation above. Now, I would like you to note that the whole list comprehension expression is in a square bracket, which simplifies or signifies a Python list. Without the bracket, Python would return a syntax error. And let's look at a typical example of list comprehension. Just as we've described this set beta notation, let's try to create such here. But in this case, our focus is to go into this list called nums. So I have a list of number from 1 to 6, and I call that list of number nums. Now, what do I want to do? I want to go into each number in this list, take the square of the number, right? As you can see, like I said earlier, concerning the general syntax of list comprehension, what appears first is usually what you want to return based on some competition. So the competition that we're performing here is taking the square root of x. For x, so I'm taking the square root of x, then I have to specify where the x should be drawn from. So for x in nums, don't forget nums is this list of numbers that contains 1 to 6 inclusive. Now, I want to place a condition. If the modulus of x be if the modulus of x is 0, so what do I mean? That I mean if x is being divided by 2 and leave a remainder of 0, then return it. So what we're trying to do here is actually fish out or get the even numbers from the list of numbers we have here. Okay, so let's run this cell and see the output. When I run this, you would see we have 4, 16, and 36. So we only squared the even number given this condition. Python goes into this list for x in nums. So x is in num. The first x in num is 1. Now, once Python goes into the list, picks 1, it verifies this condition. Is the quotient when, or the remainder when 1 divides 2, is it 0? And the answer is no, because 1 can't divide 2 actually. And then Python drops that element and will not square the element. Goes into the same set and picks 2, and then tests this condition on 2. Is the remainder when 2 divides 2 0? The answer is yes. So since 2 divided by 2 gives 0, Python then squares 2 to return 4. Then it moves on to the next element, which is 3. Now it checks this condition on 3. What's the remainder when 2 divides 3? Is it 0? The answer is no. So Python drops 3 and move on to the next number, which is 4. When 4 divides 2, will I get 0? Yes, I will get a remainder of 0. Okay, I mean remainder, not will I get. Will I get a remainder of 0? Yes, I will. And then Python computes the square root of 4 and gave the answer as 16, and so on and so forth. So this is how to write list comprehension in a typical scenario. All right, so I've just explained what we have here. Now let's look at, remember I said that list comprehension is always written in square brackets. So imagine you ignore, or you decide to leave out the square bracket and have your list comprehension written out there. When we run this cell, excuse me, you notice that we have a syntax error. It says invalid syntax, and it's pointing towards some location. If I'm to use the for loop, then I shouldn't have any item defined before the for loop. That is what Python is trying to suggest here. All right, so yes, that's it. We would look at some other examples, typical examples of list comprehensions in the next video, and we'll have different examples considered in different videos to make up this series on list comprehensions in Python. I hope this introductory or introduction part of list comprehensions in Python help. I hope this video helps, and I want to believe that once you have seen this one, you'll be able to understand the subsequent videos that we'll be pushing out under this series. Thank you for watching this video. Thank you for choosing the Data Academy, and thank you for always coming around to learn about data analytics from the Data Academy. See you in the next video. Bye bye.